All right, now to solve this problem, both the molecule is symmetric, so you can begin with any one of the carbonyl compound. And suppose I begin with right hand side. This has two alpha positions, so you can begin with any one of them. The possibility is that base can abstract from any one of them. Suppose you start with this carbon. If base abstracts hydrogen from this carbon generates a negative charge. Now this negative charge on the carbon is going to attack the other carbonyl compound. Now when it attacks the other carbonyl group, then this carbon is going to form a bond with this carbon, so this open chain is going to close and a ring formation will occur. So the number of members in the ring would be 1, 2, 3, 4, 5, 6, 7, 8. 8-member ring is not a stable ring, and 8-member ring generally will not form if you have other options available. Now if you abstract, or if the base abstracts hydrogen from the other alpha carbon. Now if base abstracts hydrogen from here, then this carbon will develop a negative charge, and this carbon will now go and attack this carbonyl group. So this carbon is going to form a bond with this carbon, so this open chain is going to close and there will be a ring formation with 1, 2, 3, 4, 5, 6 member in it. And 6-member ring is the most stable cyclic ring. So this ring formation is more favorable. So actually almost all of the product will be the one in which the cyclic ring will be a 6-member ring. So to draw the product, what you will do is make a 6-member ring, and this carbon will have a OH after the attack and protonation. So draw the OH. This carbon also has a methyl group, so it gives the methyl group. And 1, 2, 3, 4, 5, 6, sixth carbon has a COCH3 group on it. So if we are considering this as the carbon number 1, this carbon is carbon number 6. So it has COCH3 group on it. So this is the product we are looking at. Now this is the ketol. If you condense it, if we provide heat to this ketol, then condensation will occur and you have to remove a water molecule judiciously in such a way that the unsaturated product formed henceforth is the most stable possible one. Now you can do a mistake if you abstract a hydrogen from here and this OH. If you do that, alkene will form at this position. And if we draw it, this is the position at which alkene will be formed. There is one methyl and this COCH3 group is there. Now if you see, this alkene and this C double bond O are in isolation because of this carbon. This carbon is sp3 hybridized and this is isolating this C double bond O and C double bond C. So there is no resonance. If there is no resonance, then there is less stability. If there is resonance, then that provides more stability. So generally we have a conjugated alkene, conjugation with C double bond O. So if alkene comes at this position, then this alkene and this C double bond O can undergo resonance with each other. So this is not the most stable possible product. So this is not the one which you are going to report as the product, because you are expected to report the major product. So there is a hydrogen here, and if you remove this hydrogen and this OH group, then there could be a formation of alkene at this position. So the major product will be the one in which the alkene is in conjugation with C double bond O. So this is the product that you will report. Okay. Now we will solve two more problems from IIT JEE paper, and then we will move to the next reaction. So in 2008, IIT JEE gave one problem based upon aldol condensation and few other reactions. So we are going to do that now. The problem reads like this. It was written, it was a comprehension. So I'll not write the whole comprehension, but I'll write the part in terms of reactions. The problem was like this: a tertiary alcohol H upon acid catalyzed dehydration. So these things were written in words. I'm writing in the form of reaction. H is a tertiary alcohol. H is a tertiary alcohol, and H upon acid catalyzed dehydration gives a product I. So this is what you get from H, I. Ozonolysis of I leads to compounds J and K. Now they have not mentioned reductive ozonolysis or oxidative ozonolysis, but we will consider it to be a reductive ozonolysis because what they will talk henceforth will be applicable only if you consider reductive ozonolysis. We'll see what ozonolysis of I leads to compounds J and K. Compound J on reaction with KOH gives benzyl alcohol. And compound L. Whereas K on reaction with KOH, K on reaction with potassium hydroxide gives only M. This is the problem statement. They have given the structure of M. They say that M is this compound. Fine. That completes the comprehension. Now the questions. Question number 1 coming out of this comprehension is compound H is formed by the reaction of, and they are giving 4 options. We'll see one by one. First of all, look into the comprehension, and first of all you find all of them. We'll convert the problem like this. I'm changing the question, and the question is like this. You find all of them. You find H, I, J, K, L and M. So whatever, once you identify all of them, so whatever the question is, you will be able to answer that very easily. So this reaction involves aldol condensation. So it's pretty easy for you because you have just studied aldol condensation. So the structure of M is given. From that structure of M, you will identify K. And once you identify K, then what you have to do is you have to identify J and L. After that, you have to identify I, and then you have to identify H. So try to work this out. Let me see. Let me just check if the reaction from J to L plus benzyl alcohol. Okay. Now the problem here is this reaction from J to L plus benzyl alcohol. This is a Cannizzaro reaction, and we haven't studied Cannizzaro reaction yet. So what I'll suggest you to hold down, hold your breath, hold your energy. The very next reaction is going to be Cannizzaro reaction. And the mistake here is they didn't say that this KOH is a concentrated KOH. Otherwise the Cannizzaro reaction will not occur. They have just mentioned it KOH. So we have to consider this KOH as concentrated KOH. And this step from J to L plus benzyl alcohol, this involves a reaction that we have not studied yet. So I'll hold this conversion problem until we study that reaction. So you do one thing, you just note down this conversion. If somehow you know what Cannizzaro reaction is, then you go ahead, solve it. In case you don't know what Cannizzaro reaction is, then listen to the lecture for 10 to 15 minutes more, and then you will be in position to solve this conversion problem. So then we have to hold this conversion problem now until we study Cannizzaro reaction. So then we'll solve one more problem of JEE paper 2007. I'm not rubbing this off. I'll just utilize the rest of the space. The problem is like this. Cyclohexene on ozonolysis followed by reaction with zinc dust and water gives compound E. So you have cyclohexene on reductive ozonolysis. You get a compound E. And then compound E on further treatment with aqueous KOH yields compound F. You are adding KOH on E and you are getting F. So they are asking you to identify compound F. This was in JEE paper 2007. So they have options, and I'll write down those options for you. Now I have to rub this off. And then you try to identify the correct option among them.